mga kababayan, ang pambansang awit ng Pilipinas.
Kayang mag-ibig, helas ng sinangalan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyag ka ng magiting, sa mandulupin, di ka pasisigil, sa nagatang tutok sa simoy at sa langit kong pagaw, ay hinatang tula, kawin sa pagkayang minamahal, ang isang ng matawad mo'y tagumpay na nag-iingin, ang bituin at araw niya kailan pamay di magdidinig, luma ng araw ng walhagit pagsinta, buhay langit sa piling mo. Ang inigaya na pagkay mga amin, ang mamatay ng dahil sa'yo.
A prayer for teachers. Giver of all wisdom and greatest of all teachers, look upon our teachers with love. Grant them the resolve to nurture our eager minds and to never give up on us who fall behind. Bless their hearts, for they rejoice when we succeed, and encourage us when we fail. Endow them with gentle patience, for the path of learning is never easy. Kindle a spirit of passion in them. It is the flame that ignites the love of learning in us. Help them see the potential in each student. Their belief in us means much more than the grade we make. Instill in them a commitment to keep on learning. It shows us to not fear new knowledge and experiences. Inspire them to touch the future. They influence how big a dream we dream for ourselves. Bless our teachers who have come before, for their work endures to this day. Let the light of your example shine upon all teachers, to build up with their words, to love with their mind, to share with their heart. Amen.
Nothing in life is to be feared. It is only to be understood. Now is the time to understand more so that we may fear less. Great morning, everybody. Welcome to our Division webinar series on science content and teaching strategies on the context of the most essential learning competencies for Grade 9 Quarter 2. I am Rica C. Valentos from Bonifacio Camacho National High School.
And I am Shane A. Lee from Marvelous National High School, Alice Asim. We are your moderators for today's webinar. This webinar is really a productive one, since there will be lots of learning from our well-equipped speakers later on. So let me share first the objectives or goals of today's webinar. First, this webinar aims to enhance the content knowledge and pedagogical skills of science teachers in teaching science from grades 3 to 12.
Second, to capacitate all science teachers in content and teaching strategies in the context of the most essential learning competencies, or the MELC, using various platforms and modalities that teaching and learning may available at all levels.
To ensure the smooth course of our program, everybody is expected to follow simple house rule. Be prepared, be attentive, be active, and be polite.
This kind of seminar won't be possible without the support of each and everyone. And we are truly blessed to have this person who continually support and empowered us. So, to give us an inspiring message, let us welcome our brilliant and hardworking Science Education Program Supervisor, Dr. Edwin Riel Bermelio. Good morning, sir.
Happy New Year, everyone. My respect and greetings to our school's Division Superintendent, Dr. Romeo M. Alip, to our Assistant Schools Division Superintendent, Sir William Roderick Fallurin, to our Curriculum Implementation Division Chief, Dr. Milagros M. Peñaflor, to the Program Management Team, Learning Facilitators, Science teachers from grade 3 to senior high school, including alternative learning system, to our dearest students and parents, magandang buhay po sa ating lahat. Positive feedbacks were received from the first wave of our webinar as a good start that signified that the science department could conduct webinar in the different grade levels from grade 3 to senior high school using this platform and live stream at Bataan Science Channel. Expectedly, the task of teachers will be more challenging than before, considering that in this new normal setting, we in the SDO Bataan need to embark appropriate strategies and approaches to be able to realize our desire to make science education continue amidst this health crisis. This second wave of our webinar series is aiming again to enhance the content knowledge and pedagogical skills of our science teachers as necessary preparation for us to effectively deliver the most essential learning competencies and skills to our teachers and learners for the second quarter. This webinar series is only part of what we intend to do under the new normal to augment the educational needs of our students. It is a perfect tool that offers a myriad of information on science content, teaching strategies, and innovation in support to science curriculum that will help them to adapt to changes in the latest teaching and learning system under the new normal. To our learning facilitators and program management team, thank you very much for accepting this challenge. I know we can do this with God's grace, and we will be able to survive and face the whole new world of educational learning experience with confidence, integrity, and most of all, with the different competencies that we have. Maraming salamat po sa lahat. God bless everyone. Keep safe po.
Thank you so much, sir, for that very challenging message.
Another message will be shared by our ever-supportive, passionate, and dedicated Chief Curriculum Implementation Division, Dr. Milagros M. Peñaflor. Good morning po, ma'am.
Hello everybody, good to be with you again after the first quarter. Here we go to the next station, the second quarter. Thanks to you, my dear science teachers, for the continuous effort of providing our learners with skills, not only for mastery, but most importantly, for developing higher order skills on critical thinking and creativity. My gratitude to our science supervisor, Dr. Edwin Barbillo, for all the initiatives. This move really provides our unit, the Curriculum Implementation Division, a great help in realizing its goal of providing basic education services to our clienteles. On behalf of our Schools Division Superintendent, Dr. Romeo M. Alip, I would like to congratulate the Science Department, our teachers, our department heads, our principal science coordinators for improving science instruction that eventually lead to improving learner performance. Thank you for all your efforts. Congratulations and God bless us all.
Thank you, Mom, for always giving your precious time to be with us today, for your love and unending support to the division.
Thank you so much, Mamila. So, grade 9 teachers, Ma'am Shane, are you ready to listen to another fruitful discussion of science content? Ready ka na ba, Ma'am Shane?
Yes, Ma'am Rika.
Ready na tayo. Okay, so ilang months na rin po nang sinimulan natin ang distance learning. Naging challenging man sa ating lahat ang opening ng klase. We embrace the changes brought about by this new normal class. And we believe as days, weeks, months passed by, we can continually bring the quality education among our learners.
And to begin our today's session, let us welcome our first speaker for the topic of Ionic bond. She is a MAED graduate at Bataan Peninsula State University. She's 9 years in teaching and a Teacher 3 of Hermosa National High School. She is none other than Ma'am Mariafe M. Ignacio. Good morning po, Ma'am.
Morning, Ma'am.
Good morning, everyone. Welcome to our Division webinar series on science content and teaching strategies in the context of the most essential learning competencies for grade 9 science teachers. For today, allow me to discuss Ionic band. Please bear with me as I discuss the topic and questions to be answered later on. I am Mariafe M. Ignacio, Teacher 3 from Hermosa National High School that will serve as your first facilitator. We all know the K-12 curriculum was modified to most essential learning competencies due to pandemic. Here is the modified curriculum of grade 9 science for second quarter. So as we can see, we have 7 competencies for second quarter, and on my discussion, it is all about the third competency, which is explain how ions are formed. To start with this, it is important to understand what will be the objective. The objectives for today's topic are the following. Explain the formation of ionic band. Describe the characteristics of an ionic band. State the octet rule and show the valence electrons of an atom using Lewis dot diagram. And describe how ions are formed. Everything in the world around us is made up of atoms, which are tiny pieces of matter. Different atoms stick together to form all kinds of things in the world. Let us watch this video.
Chemical bonding. Almost everything we see or touch in our daily life is the result of a chemical bond. The air we breathe, the food we eat, the clothes we wear, and so on, are all made up of one or more chemical bonds. The world is generally not composed of isolated atoms. Rather, it is composed of molecules formed as a result of chemical bonds. The strong force that holds together the constituent particles, atoms, ions or molecules in a chemical species is known as chemical bond. The chemical bonds are broadly classified as ionic bond, and covalent bond. Let us discuss these chemical bonds in detail in this module. The bonding which results due to the complete transfer of valence electrons between atoms is called ionic bonding.
Chemical bond is the electrostatic attractive forces between atoms strong enough for the atoms to act as a single unit. This attraction is created by the transferring or sharing of electrons. We need to know about electrons' ability to attract each other, and each transferring or sharing of electrons is going to make the difference. Usually, this involves the valence electrons.
Valence electrons are the electrons in an atom's outermost energy level that determine the chemical properties of an element. It is valence electrons that are responsible for holding two or more atoms together in a chemical bond. Bonding occurs because atoms with incomplete outer energy levels are unstable. By forming bonds, atoms completely fill their outer energy levels and become stable using the octet rule. So, chemical bonds are like a glue that holds the atom together. The focus of our discussion is about ionic bond, which is one type of chemical bond.
Let us learn more about ionic bond, definition, and its properties. First, we must know what are ions. When electrons are transferred, atoms become ions, specifically cations and anions. Unlike atoms, ions have an electrical charge because they contain an equal number of protons and electrons. What are the types of ion?
There are two types of ions, cations and anions. All atoms have neutral charge because they have an equal amount of protons and electrons. But when an atom loses one or more electrons, it becomes a positively charged ion. And this type of ions are called cations. But when an atom gains one or more electrons, it becomes a negatively charged ion, and this type of ions are called anions.
It is very important to know what is ionic band, also known as electrovalent band. Ionic band is the electrostatic attraction between positively and negatively charged in an ionic compound. Generally, when it comes to ionic band, it is formed when electrons are transferred between atoms, metal to nonmetal, to produce positively and negatively charged ions. These ions are held together by a strong electrostatic attraction called ionic band. Remember that metal atoms lose one or more electrons in order to achieve a stable electron arrangement. This means that ionic bands are formed by the complete transfer of one or more electrons. It will also serve as a guide that to be stable, one element needs to give while the other accepts. So, it is very important to know ionic bands and its properties by watching the next video.
The ionic bond formed between the cations and anions is very strong. The ions are arranged in a regular geometric structure called crystal lattice. Different ionic compounds have different crystal forms. Naturally occurring ionic crystals are found in rocks and minerals. They are mixed with transition metal elements to give rise to brilliant colors. Have you ever seen some of these rocks and minerals? Ionic compounds have very high melting and boiling points. The ions in a crystal lattice are closely packed together, creating a strong electrostatic force of attraction between them. The more ions there are in a crystal structure, the stronger the ionic bond. Therefore, a large amount of energy is required to overcome these bonds. Table salt melts at 801 degrees Celsius and boils at 1413 degrees Celsius. Ceramics, which are made of ionic compounds, are an effective heat-resistant material suitable for cookware. Ionic compounds are hard and difficult to separate because of the strong electrostatic attraction between ions. But ionic compounds can also be considered brittle. For instance, when pressure or a mechanical force is applied, like striking a hammer on the crystal, it will cause charges to move closer. This results in electrostatic repulsion, which will be enough to split the crystals. When ionic compounds are dissolved in water to form an aqueous solution, the cations and anions are dissociated or separated and are free to conduct electricity through the solution. These ionic substances that conduct electricity are referred as electrolytes. When an ionic compound like salt is dissolved in water, the ions break out individually into cations and anions. These ions are then free to move. When the electrodes are dipped into the salt solution, the cations flow into the negative electrode, while the anions flow into the positive electrode, causing electricity to flow. Solid ionic compounds do not conduct electricity. Instead, they are good insulators. This is because the ions are locked into its crystal lattice, and ions cannot move out, so the solid cannot conduct electricity. Only ionic compounds in liquid, molten form, or aqueous solutions are good electrical conductors.
As a summary on properties of ionic compounds. Most ionic compounds are crystalline solids at room temperature. Ionic compounds are hard, rigid, and brittle. They shatter when they are hit. Ionic compounds have high melting and boiling points. Ionic compounds are usually soluble, can dissolve in water. Ionic compounds do not conduct electricity when they are solid because the ions are packed together and cannot move. They can, however, conduct as liquids because the charged ions in the dissolved state are free to move. Electrolytes.
Let us explore the typical method for depicting valence shell electrons and chemical bond, namely octet rule and Lewis dot diagram. Let us watch another video.
Hello and welcome to an EH Productions chemistry animation video. Today I'll be showing you how an ionic compound is formed through an animation. An ionic compound is a compound that contains elements that are metals and elements that are nonmetals. Today's example will be sodium chloride. So here are the Lewis dot diagrams for sodium and chlorine. As you can see, sodium, like other group 1 elements, have 1 valence electron, and chlorine, like other group 17 elements, have 7 electrons. Generally, atoms want to have 8 valence electrons because they want to be stable like the noble gases. This is called the octet rule. In this case, because we're dealing with ionic bonds, atoms would either take electrons or give electrons. Since sodium has only 1 electron, it's much easier to just give 1 electron than to gain 7 electrons. On the other hand, chlorine has 7 electrons, and of course it's easier to just take 1 extra electron rather than to on the diagram and a charge on the upper right corner.
The octet rule states that the atoms lose, gain, or share electrons in order to acquire a full set of 8 valence electrons, the stable electron configuration of a noble gas.
Let's move on how ions are formed. And since the focus of our discussion is about formation of ions, let us first discuss the formation of cations. Cations are positively charged ions. They are formed when an atom, usually a metal, loses valence electrons. Atoms that lose electrons have more protons than electrons and so have an overall positive charge and are smaller in size than the original atom. The charge of cations is given by the number of electrons lost, followed by a positive sign symbol. Example, 2 positive. The formula of cations is given by the chemical symbol, followed by the charge. Example, Mg2 positive. Let us have an example. Sodium atom has 11 protons and 11 electrons. So it has a positive charge of 11 and a negative charge of 11. So an overall charge of 0. While sodium ion has 11 protons and 10 electrons. It has a positive charge of 11 and a negative charge of 10. So an overall charge of 1 positive. 1 electron is lost by the element sodium. Let us have another example. Magnesium has 12 protons. It has 12 electrons. So it has a positive charge of 12 and a negative charge of 12. So an overall charge of 0. For magnesium ion, it has 12 protons and 10 electrons. So it has a positive charge of 12 and a negative charge of 10. So an overall charge of 2 positive. For magnesium, there are 2 electrons lost. Formation of anions. Anions are negatively charged ions. They are formed when an atom, usually a nonmetal, gains valence electrons. Atoms that gain electrons have less protons than electrons and so have an overall negative charge and are larger in size than the original atom. The charge of anions is given by the number of electrons gained, followed by a negative symbol. Example, 2 negative. The formula of anions is given by the chemical symbol followed by the charge. Example, S2 negative. So let us have an example. Fluorine atom has 9 protons and 9 electrons. So it has a positive charge of 9 and a negative charge of 9. So an overall charge of 0. For fluoride ion, it has 9 protons and 10 electrons. So it has a positive charge of 9 and a negative charge of 10. So an overall charge of 1 negative. Fluorine gained 1 electron. For sulfur atom, 16 protons and 16 electrons. So it has a positive charge of 16 and a negative charge of 16. So an overall charge of 0. For sulfide ion, it has 16 protons and 18 electrons. So it has a positive charge of 16 and a negative charge of 18. So an overall charge of 2 negative. Sulfur gained 2 electrons.
We have previously learned about the formation
For more
of ions.
understanding,
Now
let us
we will
watch
learn
this
about
video.
ionic bonds. Ions, as you already know, are formed from the loss or gain of electrons. Electrons, however, do not suddenly appear or disappear. They are in fact transferred from one atom to another. Let's look at sodium chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bonds. The same thing happens with magnesium and oxygen. Why don't you grab a piece of paper and a pencil and draw the resulting ionic compound, magnesium oxide? Please pause the lesson and resume when you are done. Magnesium transfers its 2 valence electrons to oxygen, forming a magnesium ion and an oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond. Did you get this right? Did you remember to include the charges on the ion? Now, let's look at calcium and chlorine. Calcium loses 2 electrons to form a calcium ion. One of these electrons is transferred to a chlorine atom, and another is transferred to another chlorine atom, forming 2 chloride ions. The calcium ion is electrostatically attracted to the 2 chloride ions because the opposite charges must fully balance each other out. In all 3 examples, the resulting ionic compounds have an overall neutral charge because all charges are fully balanced out. In summary, an ionic bond is defined as the electrostatic attraction between oppositely charged ions. When an ionic compound is formed, the charges must be balanced so that the resulting ionic compound has an overall neutral charge.
Here are some resources that I use for this presentation.
Thank you, Ma'am Fe. We have learned something about ionic bond, and you have discussed it comprehensively as to how is it formed and what kind of attraction do these ions hold together.
Okay, so thank you so much, Ma'am Fe. May ilan lang na mention si Ma'am Fe na na-jot down natin, Ma'am Shane. So, it is true that everything around us is made up of an atom. Almost everything we see consists of chemical bond. And this particular topic, kapag nasa klase po kasi tayo, most of the time, dapat ang estudyante meron muna siyang natutunan about metal, non-metals, positive, negative. So, yun, medyo ano din tong topic kasi ni Ma'am Fe. Sa part ng student, medyo mahirap. Pero with the guidance teacher, I'm pretty sure makukuha po at makukuha yan ang ating mga learners. Okay, so again, maraming salamat, Ma'am Fe. Bago tayo mag-proceed, Ma'am Shane, para sa ating next speaker, ano natin yung presensya ng ating mga teachers, ma'am. I-acknowledge lang natin na kanilang mga messages na nasa ating chat box. Good morning daw sa lahat ng mga teachers, ng mga na nasa Lamao National High School, sa mga taga Pablo Roman National High School. Good morning po sa inyong lahat. At shout out kay Ma'am Fe M. Ignacio, ang galing. Co-teacher namin yan. From Ma'am Lizette Fabian. They are also watching from the Hermosa National High School, Maine. Go, 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 Ma'am Fe. Thank you daw po. Ayan. O, di ba live na live tayo, Ma'am Shane?
Yes, Ma'am Rica.
Okay, so another interesting topic to be discussed is the mole concept and percentage composition. Our speaker is a graduate of Bachelor of Secondary Education, major in General Science. She's 10 years in service, a teacher 1 at Samal National High School Annex, none other than Ma'am Ethel M. Pena. Good morning po, ma'am.
Thank you, Ma'am Rica and Ma'am Shane. Good morning, everyone. Welcome to the Vision Webinar Series on Science Content and Teaching Strategies in the context of the most essential learning competencies for Grade 9 Science teachers and ALS. I am Teacher Ethel from Samal National High School Annex, and my topic is under Module 4 entitled Mole Concept and Percentage Composition. Let me introduce to you my learning competencies or my objective. First, use the mole concept to express mass of substances. Then, determine the percentage composition of a compound given its chemical formula and vice versa. Let me begin my topic through a question. Have you ever wondered how many stars are there in the sky? Can you count all the stars? How about a tablespoon of salt or a kilo of rice? Can you determine the number of particles in a tablespoon of salt or number of grains in a kilo of rice? It is impractical to try to count or visualize all these particles or atoms, but scientists need a way to refer to the entire quantity. And their solution is the concept of the mole. The word mole was introduced by Wilhelm Oswald, who derived the term from the Latin word moles, meaning a heap or a pile. A mole is simply a unit of measurement. 1 mole is defined as 6.02 times 10 to the 23rd atoms. The mole becomes a counting unit like the dozen. Like for example,
1 dozen of eggs has equivalent of 12 pieces of eggs. But in terms of mole, 1 mole of eggs is equivalent to 602 countless moles of eggs. Imagine we are in a grocery store that uses mole. Let's say we're going to buy a grapes, a bottled water, or a chocolate. For 1 mole of grapes, it is equivalent to 6.02 times 10 to the 23rd particles of grapes. For 1 mole of pure water, it is equivalent to 6.02 times 10 to the 23rd molecules of water. And for 1 mole of pure chocolate, it is equivalent to 6.02 times 10 to the 23rd atoms of chocolate. So we need to remember that anytime we are counting how many items or particles we have in terms of mole, 1 mole has a constant value of 6.02 times 10 to the 23rd items or particles or atoms or even molecules. And this Avogadro's constant is known as the Avogadro's number, which is equal to 6.02 times 10 to the 23rd particles or atoms. Is the number of particles or atoms in 1 mole of a substance, and denoted by the symbol caps lock N sub caps lock A. N stands for the elementary entities of the sample, and caps lock A for Avogadro's number. For a very short trivia, the Avogadro's constant is named after the early 19th century Italian scientist. He is Amedeo Avogadro, who in 1811 first proposed that the volume of a gas is proportional to the number of atoms or molecules regardless of the nature of the gas. His full name is Lorenzo Romano Amedeo Carlo Avogadro di Quaregna e di Cerreto. He is most noted for his contribution to molecular theory, including Avogadro's law. He conducted a series of experiments leading to the mole concept. Okay, for sample calculation, how many moles is equivalent to 1.355 times 10 to the 24th atoms of gold? Using the dimensional analysis, we have the unit equality. 1 mole of gold is equals to 6.02 times 10 to the 23rd atoms of gold. Then the desired conversion is from atoms to moles. For calculation, 1.355 times 10 to the 24th atoms of gold multiply to 1 mole of gold all over by 6.02 times 10 to the 23rd atoms of gold will give us 2.251 mole of gold. Another example. How many molecules of carbon dioxide is 0.0357 moles? For dimensional analysis, unit equality, 1 mole of carbon dioxide is equals to 6.02 times 10 to the 23rd molecules of carbon dioxide or CO2. The desired conversion is from mole to molecules. The answer will give us 2.15 times 10 to the 22 molecules of carbon dioxide. For my dear teachers, can you make the following mole conversion using dimensional analysis for 10 seconds? How many mango seeds are equal to 3.50 moles of mango seeds? You may write your answer in the chat box. Is it A, 2.11 times 10 to the 26 power of mango seeds? B, 2.11 times 10 to the 24th power of mango seeds? C, 2.30 times 10 to the 24th power of mango seeds?
Ten, 9, 8, 7, 6, 5, 4, 3.
We cannot literally count the number of atoms in a sample, but we can count them using mass. The relationship of mole and atomic mass is known as the molar mass, having a unit of grams per mole. Molar mass is the mass of 1 mole of an element or compound. It is numerically equal to the molecular weight of a molecule or the atomic weight of an atom. First off, there are many names for molar mass. It can be named as molecular mass, molecular weight, and gram formula mass. The mass of 1 mole of a substance. How to calculate for molar mass? Let's do an example for aluminum hydroxide. First, let us identify the element involved in a given compound. Then, identify the number of atoms together with their atomic mass. So, for the element, we have the aluminum, the oxygen, and the hydrogen. For their number of atoms, by merely looking with the chemical formula, we can identify the number of atoms. Aluminum, 1, oxygen is 3, and hydrogen has 3. While their atomic mass can be found out into the periodic table. For aluminum, atomic mass unit 26, oxygen is 16 atomic mass unit, and hydrogen 1.01 atomic mass unit. Let us now calculate for their molar mass. Let us now calculate for their molar mass. To get the molar mass of each element in a given compound, simply multiply their number of atoms into their atomic mass. And so for the molar mass of aluminum, we have 26.98, for oxygen 48, and hydrogen is 3.03. All the unit is in grams per mole. To calculate for the total molar mass of a compound, simply add the molar mass of the 3 elements. Then the total molar mass of aluminum hydroxide is 78.01 grams per mole. Let's do the calculation for molar mass of calcium hydroxide. So the element involved, we have the calcium, the oxygen, and hydrogen. For the molar mass of calcium, we have 40.09, oxygen 32, and hydrogen is 2.016 grams per mole. Will give us the total molar mass of 74.10 grams. This solving is considered as the long method. There is an easiest way in getting the molecular mass of a compound. Okay, so this one is the easiest way. For the atomic mass or the molar mass for calcium. Then plus the atomic mass of oxygen and the atomic mass of hydrogen. Then bring down 40.09 plus add these two will give us 17. Then multiply it to the atomic number, which is 2. Then the total molar mass is same with the first one, 74.10 grams per mole. And for the turn of our genius science teacher, using a periodic table or even without using a periodic table, give the molar mass of the following we're going to check your answer in our chat box. So for continuation, after getting the molar mass, we can also determine the percent composition of the compound. So what is a percent composition? It is the mass of each element in the compound compared to the entire mass of the compound multiplied by 100. Following the formula, percent mass of element is equals to molar mass of element in the compound all over. Following the formula, 16, which is the molar mass of oxygen, divide it by 18 grams per mole, molar mass of compound or the H2O times 100. So the percentage composition of oxygen is 88.79. Then percentage molar mass of element, which is equivalent to 2.02 grams per mole for hydrogen, divided by 18.02 grams per mole of water times 100. Percentage mass of hydrogen is 11.21. So we therefore conclude that water is composed of 89% oxygen and 11% hydrogen. So for the lovely teacher of science, I will leave you an assignment for percent composition for glucose and nonane that you can use later on. You can make a screenshot, picture, or sheet of paper. So for the summary of my topic, I have 5 bullets of information. It ends up my topic for today.
salamat po, Ma'am Ethel, for enlightening us for the second topic of the most essential learning competencies in grade 9. Napaka-informative po ng inyong part na yan. Honestly speaking, Ma'am Ethel, medyo mahirap-hirap pag tinuturo sa mga students. Yes, di ba, Ma'am Shane? Kasi, students, they hate numbers. Ayaw nila nang nagsosolve. So, pag nakakakita sila ng number, parang natatakot na agad yung estudyante. Pero, sa iba naman, favorite part nila yan sa lesson ng grade 9. So, meron lang ilan akong na-jot down sa nabanggit ni Ma'am Ethel sa kanyang discussion. We can't literally count, tama naman yon, the number of atoms in a sample, but we can count them using mass. The mole is an amount unit similar to familiar units like pair, dozen, and it provides a specific measure of the number of atoms or molecules in a bulk sample of matter. Kaya kanina, na-catch up niya yung attention ko doon sa pasimula ni Ma'am Ethel na paano mo nga naman bibilangin yung pagkarami-raming stars. Paano mo bibilangin yung ibang mga bagay na meron tayo around us. So, sounds like impossible, but with the discussion like this, pwede nating ma-impart sa ating students na yes, we can really count yung mga ganong examples natin na familiar din naman ang ating mga students. Diba, Ma'am Shane? Ma'am Shane, ikaw, baka meron idadagdag doon.
Okay, Ma'am Ethel. Pinagaan mo ang discussion about molar mass and percentage composition of compound. So for sure, kapag yung mga estudyante ko sa Marvelous National High School, Alas-Asin, kapag pinanood nila tong webinar na ito, di ko talaga sa kanila na panoorin to kasi second quarter topic, molar mass at saka iyan. Okay? So now, teaching effectively involves not only the use of tools, techniques, and strategies to optimize students' learning, but an understanding of the context. It is very important for us teachers to know in particular.
Let us welcome Sir Ledric Talastas, Teacher 1 at Jose C. Payumo, Junior Memorial High School. Let us welcome him for the discussion, for the third topic. Good morning, sir.
Good morning, sir.
Good morning po at ako po si Trix. Ako po yung naatasan at na mag-discuss tayo ng tungkol doon po sa mga online apps na pwede natin gamitin or programs, softwares na pwede natin gamitin para mapadali po ang trabaho natin bilang isang guro o mga guro. Okay? So, without further ado, let's dive in. So, unahin natin ang Google Drive. So, Google Drive is a tatawag natin na platform na more commonly is ginagamit lamang sa atin. No? This is a Google Drive is a file storage and synchronization service developed by Google. So, maraming klase ng storage services na makikita natin sa internet. Nandiyan yung Mediafire, yung Drive isa lang, Google Drive. Okay. So, ito ang Google Drive. So, yan. So, ito yung tinatawag natin dashboard mo. So, ito naman yung mga na-upload mo ng files. So, ang Google, wait lang. Okay. Tama. So, kala ko hindi akin. So, akin pala. So, kapag ikaw ay meron ng Gmail, no, pwede mong gamitin ito. No, so, pag may Gmail ka, so, register ka lang as Gmail, yung gamitin mo, yung Google ID mo, pwede yun. Ngayon, kung tao dito, natatak pa ako no? Lipat tayo dito. Okay, ngayon kung gusto mo medyo mas mapadali na din trabaho mo dahil mayroon naman tayong mga tinatawag na official na mga ginagamit bilang email o tinatawag din DepEd email ang gamit ko, which is this one. Ayan, nakita niyo Okay, so ayan po yung ating pwede nyo gamitin. So, meron namang mga tutorial dyan para mo paano mo siya ma-utilize na gusto yung Google Drive. So, bibigay ko lang sa inyo is the basics. So, paano nga ba tayo magdadala ng file sa Google Drive? For example, so dito, pwede kang pwede kang mag-upload. Okay, syempre, pwedeng gumawa ng folder. Pwedeng gumawa ng folder muna. For example, ako gawa ko ng folder. So, lagi ko rito ay Drix Files. Ayan. So, gumawa ko ng folder. So, ito na yung folders niya. So, ito mga to is the quick access at saka yung mga recent upload. So, nga pala no,